Hi everyone, welcome to my YouTube channel Take Data Engineer. So today we will see data modeling, why this is important and that is very useful topics for data engineer for data modeling and designing the data. Okay, so what is basically data modeling? So data modeling is nothing but data modeling is the process of creating a visual representation of or a structure that define how data is organized. Okay, so suppose if you talk about the Amazon, so how the data structure would be. So there are some customer data, some warehouse data, how the transition go, how customer place the order, how this order will dispatch from different warehouses, how it will went to the different destinations. Okay, the customer address and all. So this all designing, so from your source system to your destination system, and what are the, you can say, intake in that particular entire source to destination journey. So designing all the data movement is basically a data modeling. Okay, so this data modeling, what we will do in a first go, whenever we have problem statement, this we will design on high level. So there are different data model also, we will see all this. So data modeling is nothing but data modeling is the process of creating visual representation or a structure that define how data is organized, stored and manipulated within a database or information system. So if we have information system, so what type of data we have a structured data, unstructured data. So what are the based like what are the base storage system for storing that data? If it is I can say document based, or it is relational data, or it is JSON data. So what type of data you have, based on that your information system you have to design. Okay, so why we are designing the data model basically, because it helps to define the relationship. Okay, so there is a relation like customer address. So what is the relation between customer and customer and order? So if one customer placing multiple order, or one customer placing one order, so what is the relation between customer and order? Okay, one to one or one to many. So this is basically define the relationship of it, define the relationship attributes and relationship between them. Okay, so the purpose of data modeling is to ensure that the data is accurate, accessible and efficient for querying and analysis. Okay, so because of data modeling we get to know the data is moving accurately. Okay, that is accessible from anywhere and efficient for querying. So whenever required, so it is efficient, we can query the data. Okay, so that is the data modeling. So there are some key concepts which is basically used in data modeling. It's like entity. Okay, so entity is nothing but, if you'll talk about the Amazon thing, so we have product, order, customer, these all are the entity. So entity is nothing but the object or concept that are important in the domain. So in that domain, like suppose Amazon case, so there are one important domain is order, one is the customer. So this customer and order are basically entity. So what are the attributes? So attributes is nothing but their behavior and their, you can say, feature, you can say. So order have the feature like order ID, order amount, quantity. Similar way we have customer have the feature like name, email, address, city, zip code. So these all are the attributes. Then now comes to relationship. So relationship you will define, we have already discussed like order and customer. So what is the relationship between order and customer? So one customer can purchase multiple order, one customer can purchase one order. Okay, so this is one to one relation or one to many relation. Okay, so these types of relationship we required to designing a data model. Then what are the primary keys? So primary key is nothing but this is the uniquely identifier. So if you have 100 records, so based on which column we can uniquely identify the record. So that is basically the primary column, primary key. So primary key, so in normal cases this some id should be the primary key, or you can say the combinations of id also sometimes used as a primary key. Okay, then foreign key. So foreign key is nothing but foreign key is one entity refers to primary key of another entity. So there are two tables. Suppose we have order table and we have customer table. So customer have order id, and in case of order table, order have order id. So some one table primary key is referring to other table, so that is called foreign key. Okay, this is basically for joining the two table, or we can say interlinked between the two table, we design foreign key also. Okay, now come to the so these are the, so we understand that what is data model. So data model is the process of creating visual representation that define how the data is organized, stored and manipulated within a information system. So that is called data modeling. And data modeling have all these concepts like entities, attribute, customer, relations, primary key, foreign key and many more. Okay, then talk about the what are the types of data model. So we have three data model: conceptual data model, logical data model and physical data model. So conceptual data model is the high level view of data, focusing on what the system needs to store without worrying about how. So conceptual is basically deals with how, what. Okay, so what is the system need. Okay, it is not worrying about how it will be implemented, only what to be done. Okay, so that is the high level view. Then comes to the logical. So logical, this builds the conceptual model and add some more details such as attribute, type of relationship, and also defines the constraint and normalizations rule in case of that. So what is physical data model? So we will see all this in the detail. So what is physical data model? So this is the implementation specific, like how the data resides in the physical storage. So this is basically the physical data model. Okay, so for some, what are the type of data you have, how we are store, if you have json based or document based or key value based. So different types of data if you wanted to store, so what should be your physical data model? So that should be so based on that you will design your physical data model. Okay, so what is the benefit of data modeling? So basically data modeling gives the clarity. So it provides the clear understanding of data requirement and structure. So if you have the data model, so okay, you will get to know that what are the components there, what are the attributes, relationship, and what are the storage system you have. Okay, you can see the consistency also, like that ensure the data is stored in a structured and organized manner to reduce the redundancy. Then efficiency, in case of your data modeling, you'll get the, if you have already designed your data model based on your use case, so that helped in optimizing the data query and you improve the overall system performance. Okay, so obviously if you have data model, the data integrity comes, like ensure that data is accurate and reliable at each stage of the system. Okay, based on certain rules and constraints. Okay, so there are certain data model techniques also. So the one is the er diagram, which we have already represented, we've already seen in that. So the er model is something like entity, relationship, attributes and all, multi-valued attribute, single valued, composite key. So this all are the er diagram. So first we have to design the er diagram, then after er diagram we have comes like normalizations. So normalization is basically to reduce the redundancy and improve the data integrity by breaking the whole table into a smaller chunks. So if we have any redundancy in the data or certain things which is not allowed, so we have different normalization. So for that, one nf first nf, second nf, third nf and bcnf. So we have to break the data into that, so that we will see in the next video in detailed manner. So basically common data techniques we have like er diagram and normalization. Okay, so now first come to the conceptual data model. So we will see conceptual data model in the details. So conceptual data model is, which we already discussed, is a high level representation of data requirement for an organization system. So whenever we have business use case, so for that business use case, first we will design the conceptual data model. So conceptual data model, because basically focused on what needs to be done rather than how it will be implemented. So for first, what needs to be done. So if you have your information system, you will collect the what are the attribute in that, what are the entity in that, what are the relationship in that, but you will not basically worry about how it will be implemented. Okay, so it focus on what data needs to be captured and how entities are related to each other without uh, going into details of how the data will be stored or processed, because that comes to the physical data model. Okay, so this data model is concerned with what the data rather than how it will stored and implemented. So the primary focus of conceptual data model is to map out the business needs and provide the shared understanding of data requirement for stakeholder. Okay, like business architect or developers and all. So basically it ensure that the system will capture the correct data to meet the business goal. Okay, so what are the things we have to capture in your data conceptual data model is, one is the entity, like which we already discussed, like customer is the entity, product is the entity, order is the entity. With that, their relationship, what is the relationship between two entity, then what are their attributes. So customer have the attributes like name, address, city and all. Product have the attribute like product id and everything. Okay, so then the cardinality also. So cardinality comes into picture, like what are the relationship between the different entity, like one to many or many to many or one to one. So basically the relationship between the entity. So conceptual, so in case of conceptual data model, we capture these many features like entity, relationship, attribute, cardinality, okay, and many more. So if you'll see the characteristics, so it will basically, if you design your CDM conceptual data model, so it will give the high level abstractions. So in that designing, no technical constraint required, so it does not address performance consideration, latency, storage details or SQL related decisions, so you don't have to worry about that. So there is no technical constraint required. So this is basically stakeholder oriented, so functional oriented, you can say. Okay, where the basic layman term you can define each and everything, so that the business stakeholder person can understand. So this is not the technical involvement required while designing your CDM conceptual data model. Okay, so this will, most of the time this will ask in the questions, what is different between conceptual data model and logical data model. Both look same, but there are certain difference. Okay, so if you'll see, so I have taken a conceptual data model design also. Let's, you are modeling the data bookstore. Okay, so the bookstore, whenever you are designing, so main goal is to identify the key entities and how they relate to each other. So like entity have book, customer, order and author. Okay, so if you'll talk about the attribute capture, so book have the attribute like ISBN number, title, price. Then customer have the customer ID, their name, email, phone. Order have the order ID, order date, total price. The author have the attribute like author ID, first name, last name. Okay, then comes to the relationship. So what is the relationship we have to capture in CDM conceptual data model, like book to author, what is the relationship between book to author. So a book is written by one or more author. Okay, or author has written multiple book. Okay, so there are many to many relationship. In case of order to customer, so there is one to many, so always one order goes to one customer. Okay, there is no case like one order goes to multiple customer. Yeah, one customer place multiple orders, so there is one to many relationship. Then again order to book, there are many to many relationship. Then we'll see the cardinality also, like customer can place many orders. So what is the cardinality? One to many, one customer can place many orders than one to many cardinality. Similar way, so these all are the details we can capture. Okay, So if diagramical represent, you can see, so there is one customer, then customer collects multiple orders, then orders have the multiple, one order have the multiple books, so there is in many to many, then again book to author also many to many relationship. Okay, so one to n represent one to many relation, n to n represent many to many relationship. Okay, so the simplified ER, so basically you can represent in ER diagram like customer has one to many relationship with the order, order has many to many relationship with the book, and book has many to many relationship with the author. Okay, so benefits already we know that it's basically clarify the business needs, improve communications, it will helpful for a stakeholder that is not technically oriented. So this all are the uh, benefits of conceptual data model. So when to use a conceptual data model? So at the beginning of a project, okay, whenever your technicality is not comes into picture, if you have your business use case, then you will design your conceptual data model. Okay, so for high level discussion, if you are not going to the details, minor details, then you can design your conceptual data model. Okay, okay, so conceptual data model, high level abstract view of organization data focused on what rather than how it will be stored. Okay, then now comes to the logical data model. Okay, so logical data model is the process of refining the conceptual data model. So if you have already designed your high level logical, you designed your high level can say conceptual data model, then now comes the picture to refining that. So once refining comes, then that comes to the logical data model. So unlike conceptual data model which focus on the data will be focused on what the data needs to represent. So the logical data model being the address how the data will be organized. So that is the basic difference. So conceptual data model deals with what needs to be in, and logical data model deals with how it needs to be done, how the data will be organized, without yet dealing with the specific physical implementation like storage, indexing, performance. So this all comes while designing the physical data model. Okay, like storage, indexing, performance, accessibility, and all these things. But yeah, logical data model at least gives the picture of how the data will be organized and accessed. Okay, so the logical data model is the concerned with translating high level business requirement into more concentrate and concrete and a structured form that are closer to implementation, but still dependent on the actual database platform like in case of physical model. Okay, so what are the key features we are capturing? So same, we are capturing the entity, attribute, a relationship. Then so here a few other things we are capturing like a primary key, foreign key. So what are the things which can distinguish the entire record? Then normalization comes into picture. So if there is a redundancy in the data, then we go with a different level of normalization. Then constraint on business rules, some constraint like name should be only string, then can't be any integer, so, or something like this can't be null, some id, some column cannot be null. So these are the constraint and business rule that will be applicable while designing your logical data model. Okay, so conceptual data model provides a broad abstract view of what data is important and how it will related at the high level. But if we'll talk about logical data model, that takes the abstract view and refine it and define how the data will be logically structured. Okay, so same if you'll see the example by logical data model designing, customer have the customer id, first name, last name, email, phone number. Book have the book id, isbn, title, price, publishers. Similar way we are capturing each and everything, and if required we are capturing the relationship, then normalizations if there are certain redundancy, if you are not following the particular you can say normal form, then we are breaking basically the table into the different. Then business rules, so email address of the customer must be unique, so that is the primary. Quantify the order item cannot be negative, so any quantity cannot be negative. So these are the business rules, that is the constraint which applied on the table. So similar way we have represent the ER diagram of the logical model also, like one to n relationship, customer to order have one to many, then order to order item have one to many, then order item to book have many to one, then book to author have many to many. Okay, so for benefits of defining your logical data model is we will get the clearer structure. So it provides a clear and more detailed picture. Business rule enforcement, so if certain rules needs to be enforced, like quantity can't be null, or tax can't be null, or certain things, so an order quantity or order quantity can't be like can't be negative, so this all you can define. Okay, so now we will see difference between conceptual, logical, and physical data model, like focus on abstract level and this all. So conceptual, logical, and physical data model, these are the details basically. So what data is required and how it is related, and how data will be structured logically, and how data will be implemented physically. So these are the difference between them. Okay, thank you, thanks for watching.